how to evaluate installation instructions when building for performance and protection in high-velocity wind zones. Welcome to Building Knowledge 101. In this video, we explore how to evaluate and understand installation instructions for building performance and protection in high-velocity wind zones, looking at mullions, insulating glass units, and entry options. So here's the first chart in the installation instructions, and this one is looking at what your mullion option is going to be. So what we're going to start out with is what is our maximum design pressure. So in this application or this example, let's choose 90. So I've boxed over on the left all the examples of where the design pressure of 90 is used. Now we're going to locate the height of our mullions on the chart. So in our project, we're going to say our mullions are 130 inches tall. So over here on the left, we're going to find what category here fits 130. So that's going to be right here with a maximum of 132. Now we're going to look at what the mullion spacing is. So our mullions in our example are 60 inches on center. So we're going to find 60 here in the width and then come across here. We see we have two mullion options. We can use mullion option 2 or 3. So we're going to go with mullion option 2 because that's going to be the more economical. It doesn't have as much steel as mullion option 3. So we don't want to buy steel if we don't need it. So we're going to go with mullion option 2. So let's change it up a little bit. Let's say our maximum design pressure was 83 PSF, and we're going to make our elevation a little bit taller. We're going to go with 144. So now I've boxed out where maximum design pressure of 83 is on the right, and then my mullion height on the left. Now we're going to look at our spacing. It's 48 inches on center. So you can see we only have one option here. We can only use mullion option 3. So if we didn't want mullion option 3, we could reduce the height of our elevations and get us down to where we could use mullion option 2 or one of the others. But you can see, based on the way you've drawn your elevation, you need to come into the charts here and see what your mullion options are. Here's another example of a mullion option chart. Looks different from the one we just looked at, but it really gives you the same information. You can see your maximum design pressures, and then you can see the spacing of the verticals and the height and what your mullion options are. Now, anchors is also called out in the installation instructions. So anchors are driven by the surround condition. You can see here we got 3 different options. There's steel on the left, concrete, and wood. And then also note at the top here is calling what the maximum in reaction is. So you want to make sure that on our project, our in reaction doesn't exceed 1,800 pounds for the example we're looking at here. So let's say we're anchoring into concrete. And so we'll pull up the chart here and we'll realize that as far as our anchoring options, we have 2 that are listed here, D and E. Then here in the chart, it's going to explain what D and E are. Those are our anchor options here. Now, if our wind load exceeded 1,800 pounds, we need to go to another chart. You can see here's another one here that goes up to 2,475 pounds in reaction, and it gives us different anchor options here. So going through the charts here, making sure that we choose the anchors appropriate for every application is very critical. Next, we need to look at glass. Let's evaluate if our glass sizes are within what was tested. So here you can see an example of a curtain wall horizontal detail. The glass bite is indicated, and the width of the structural silicone seal, which is adhering the glass back to the frames, is called out here. So you can see those critical dimensions shown there. And then it describes one of our glass types. Glass type 1 is called out. This is your typical impact insulated glass unit and impact application. The total depth is 1 5/16 thick. So it has 1/4 inch tempered glass on the outside, 1/2 inch airspace, and then your laminate inner layer. So now we're going to go to a glass chart. The glass chart is going to tell you what your daylight openings are and what the maximum DLO can be. So each project's DLO can't exceed what's shown on this chart. Now you do have a number of different options here, but what I want you to notice is this is the width of the glass going across here, and this is the height. But notice as you get wider with the glass, the height is reduced. And as you get higher, the width is reduced. So there's a trade-off. As you get wider, you have to drop it down. So there's a maximum area you can't exceed, and it has to stay within what was tested by the manufacturer for that system. But you can vary it. There's a lot of different glass options. You can see on this project, there's a number of different sizes, but they all fell within what was tested, or they were all accounted for in the manufacturer's test. Then since you're using laminate glass, Your inner layer is something you have to check also. So also in the manufacturer's insulation instructions is going to be a description of the laminate glass. Your outboard light is considered sacrificial. So what we mean by that is in the event of a storm when there's flying debris, the outboard light is going to get broken and it's going to get lost. Where our main concern is the inboard lighted glass because that's where your protection is. So your inboard lighted glass is fabricated with a laminate layer in there to hold the broken shards of glass together, keeps it contained as a unit so it doesn't fly out, and maintains the integrity of the building envelope. So your outboard lighted glass is to the discretion of the design team. It can be whatever they're looking for, but the inboard lighted glass, it's important that it fall within what was tested by the manufacturer that you're using. So you can see an example of a chart here, and it lists different inner layer options. So most manufacturers are going to have tested a number of different inner layers. So it's going to tell you what those options are. You can see them listed here. Then it's going to tell you the maximum design pressure that that inner layer was used with. And then the glazing method. Was it wet or was it dry glazed? Typically, when using wet glazing, you've got a flexible inner layer. When using dry glazing, it's a rigid inner layer. And in some cases, you might see tape also being used. So all projects have to have entrances, and entrances are the same thing. When we start evaluating, we need to make sure the entrances that we draw stay within what was tested. So there are installation instructions to follow for entrances also. The installation instructions provide critical information. This illustration shows you the maximum size and width of the door. So you can see width across the top and then size or height down the sides there. So your door has to stay within, it can't exceed the maximum dimensions listed here. So the maximum height and then the maximum width of the door. Then also called out is going to be what the maximum design load was. So this door can't be used on an application with a design load greater than 60 PSF. Then it's also going to give you hardware options. So every manufacturer is going to test their doors with a range of hardware options. So we need to make sure we stay within one of those tested hardware options. And then your anchor details, like we looked at earlier with the fixed frames, also anchors are going to call it out on a door. So again, whether you're using pairs of doors or single doors, all of them are going to have that same breakdown of information, your maximum height and width, confirming the maximum design pressure, hardware options, and then what your anchor conditions are. So looking at anchors, anchors are driven by what the substrate or surround is. So you can see here, we've got wood or metal studs or steel or curtain wall, then here concrete. So you can see it lists now different surround conditions because in this application, we're anchored right to mason here, and we've got a transom on top of it. But in other applications, you might be setting the entry into a curtain wall. So you've got to look at the anchoring because it's going to change based on what the surround condition is. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.